Good afternoon. I'm Joseph Siraj. I'm a corporate vice president in the Artificial Intelligence and Research Group. Really excited to have all of you here at Connect. And I'm telling a story today, a story about how artificial intelligence can be infused into every application. Developers can do this today in any language, any operating system, and leverage the massive power of the cloud infrastructure to amplify the power of AI. And really, if you think about our investments in the AI platform, it's about bringing the best of the cloud to AI as much as it is bringing the best of AI to the cloud. Together, cloud and AI form the platform of the future. It's an incredibly powerful one. So it's meant to be the most open, secure, cloud-enabled AI platform ever. It composes of three major sets of capabilities. So it's a collection of higher-order services. These are AI simplified, hosted in the cloud, enabling you to easily connect into any application and then build reliable AI applications. All of that layers on top of the wonderful infrastructure in Azure, constantly being innovated upon, databases, hardware, networking, security, all of that. And then we provide a collection of tools to make all of this development much simpler and easier. Okay? So the best way to dive into it quickly is to see an application. I want to show you something right away that illustrates the power of all of this AI coming together. Now, what I'm going to tell you about is an application called HelpPicto. It is developed by a French startup called Equidex. It helps autistic children communicate. Now, autistic children use often pictograms and a sequence of pictograms to communicate, and AI can make all of that easy. So let me roll a short video to show you what I mean.
Arthur, c'est un autiste sévère qui n'a pas de langage, donc qui a une compréhension assez basse des choses, assez petite, et qui a 15 ans. Il était à la crèche. À un moment donné, on a eu l'impression qu'il ne nous entendait plus et le regard était plus vide. On est allé voir une pédiatre qui nous a dit tout de suite, il est autiste. On n'y croit pas, ce qu'on lisait, c'était pas possible. Il ne ferait pas partie de ce tableau. Et il a fait partie du tableau le plus sévère qui existe quand même. Aucun langage, il saute partout, il crie beaucoup. Donc voilà, c'est bien fatigant le quotidien. Quand il s'énerve, c'est quand même qu'il n'a pas compris quelque chose ou qu'il veut quelque chose. Le classeur, le PEC, c'est pas quelque chose d'évident, de facile. On n'a jamais la bonne carte elle est perdue, elle est tombée sous le fauteuil. On a quand même un peu ramé. D'où l'intérêt pour lui de communiquer avec HelpPicto. Je parle, je donne une information à Arthur et elle est traduite par l'application HelpPicto instantanément en pictogramme. Et après, d'une façon orale.
Microsoft a développé ce qu'on appelle des cognitive services, mis à disposition dans le cloud de la reconnaissance d'images, de la reconnaissance vocale et des traducteurs automatiques de langue. Et ça, c'est important parce que c'est nous donner la possibilité à nous, PME, d'accéder à ce qui se fait de mieux en matière d'intelligence artificielle.
C'est beaucoup plus ludique, plus facile, il comprend mieux, n'importe où, en forêt, on se balade. Et est-ce que tu veux boire? Est-ce que tu veux faire pipi? Est-ce que tu as faim? Ça paraît pas grand-chose, mais en fait c'est énorme cette différence. C'est vraiment énorme.
Plus on utilise HelpPicto, mieux ça fonctionne. Le modèle va continuer à apprendre au fur et à mesure pour faire en sorte de l'optimiser et de le spécialiser.
L'autre jour, j'ai appuyé sur « On va se doucher », il regarde la tablette et il va dans la salle de bain. Il n'y a pas eu de cris, il n'y a pas eu de larmes. Enfin, c'était waouh, c'était super, quoi. Des petites choses comme ça, c'est une grande victoire.
It's a powerful example of how AI can augment human capabilities, allow everyone to do more. And this is a schematic of that architecture. It's a Xamarin app, and data comes in. It's orchestrated by Azure Functions. It calls intelligent APIs. Process data is stored in SQLDB. Turns out to be quite easy to assemble an application like this for any developer. And you can imagine the type of scenarios, assistive technologies, where these kind of applications may be extremely powerful. So let's take a step back then and think about how AI can really help us all the types of scenarios where AI might come relevant. Now, it's a very broad set, but today I wanted to cover 4 scenarios. And they come in these buckets. First one, understanding. Okay? AI allows us to understand all types of data, understand the information, join it together, and allow us to act upon it in a predictive way. Second, AI allows us to reason and build models of the data. So remember, in the past with physics and mathematics, we used to build closed-form models of systems. Once you had a model, the model was predictive. Physics and science is all about predicting. Science is proven through the ability to predict. Well, AI does that statistically. So you learn from the data, you build models of the world with the data, and then you put that in production for future predictive applications. That's reasoning. And then third, AI allows you to create natural user interfaces, like chatbots being one example. But very soon, every type of conversation that happens, whether it be on a chatbot or any messaging platform, or all the interactions we have on our phones and web, it'll all be infused with AI. And it will make those conversations more fluid, more targeted, much more crisp, able to communicate dramatically more, and above all, to get things you want done, task completion. Okay? So now let's dive into the specific scenarios I'm going to be able to illustrate. I'm going to start with the first one being cognitive understanding of documents. Imagine a vast amount of documents being collected, documents, media, all types. Then you extract the information in it, bring it together for you to be able to use in the enterprise. The second scenario is going to be about reasoning, and I'm going to have 2 scenarios to show there. I'm going to show how to build custom AI models from data, in this case on image data. And then I'm also going to show how you can deploy it real time on the edge, whether it be on a phone or an IoT edge device. And then finally, I'm going to go to conversational AI, bots infused with intelligence, chatbots. Okay? So that's what's coming up. So let's start with scenario number 1, cognitive understanding of documents. A big part of the struggle of the digital transformation in the enterprise today is really that struggle to organize information in so many silos, in so many formats, in unstructured ways, and to bring intelligence to all of that. Here's actually an example from one of our customers. This is from Nigeria. That's all the data they wanted to actually organize, understand, and correlate. Imagine having to go figure out what's in that big pile. Every enterprise has an attic of data. They may not be as bad as this, but it may be digital, but still, it is a completely unorganized clutter, and you've got to understand all of that. So the best way to show the power of what AI can do for a scenario like this is with a demo. So let me invite Coram Thompson, who's a principal engineer in my team, to show you how you can actually connect information up in unstructured data and make a very, very powerful example out of it. Coram? Hey.
Thank you, Joseph.
Thanks for joining us.
On November 22nd, 1963, the President of the United States, John F. Kennedy, was assassinated. While driving through Dallas in this motorcade, he was shot by a lone gunman named Lee Harvey Oswald. Well, that's at least what the government wants us to believe, right? Actually, this has been such a controversy around this that 25 years ago, an act of Congress mandated that all the documents related to the assassination be released this year. Well, how many documents are we talking about here? Well, this first batch of documents contains about 34,000 pages. That's a stack of paper that's about 12 feet tall. And they just released in the last few days another batch that's even bigger. And they're going to continue to release even more information. So, are any of you guys curious about what's inside here? I know I am, right? And so I'm not really that into reading thousands of documents personally. So how should we approach this, right? So what we find is that when you need to extract understanding from a deluge of documents, it's best to use a continuous process that allows you to ingest the raw documents, enrich them with structured information, and then be able to explore the data. Now, we found that a powerful pattern to do this in the cloud is to use a pattern that we call cognitive search. This pattern feeds data into the cloud, applies a set of cognitive skills that extracts knowledge and stores them as annotations, and then creates new experiences exploring the data using search. Now, to illustrate this, what I've done is I've applied this pattern to the JFK documents. So join me as we open the JFK files. All right. This is the JFK files. It's a simple web application that I built using the AZ-Search.js library that you can find on GitHub. Now, over here on the left, you can see that these are some of the annotations that are broken down and organize these documents that we've been able to extract from the documents. So right off the bat, you can tell that these documents are about JFK, the CIA, and the FBI. Now, I think we should just start from the beginning. Let's start with Oswald. Well, now look at this. Now, it takes us right into the place in each document where it mentions Oswald. Now, this is because an OCR skill annotated these documents with the text that it's extracted. And the cool thing is that it doesn't even matter if those documents are typed or if they're handwritten, such as in these cases. Now, you may have actually noticed that one of these words, GPFLOR, is highlighted as well. On here. Now, that is not a typo. In fact, the CIA uses code words in a lot of their communications. And so GPFLOR is actually a CIA cryptonym for Lee Harvey Oswald. Now, this annotation was created by a custom skill that I created that annotates these documents using a published list of code words that you can find on the internet. Now, what this does is it means that GPFLOR and Oswald are now treated as synonyms, and so all of the results are now linked together. You may have also noticed that in addition to documents, it returned back this image. This is because we used a computer vision skill that is able to understand the contents of this image, recognize Oswald's face, and provide a caption. In this case, the caption says, Lee Harvey Oswald posing for the camera. So I'm guessing this is his yearbook photo or something. All right, now we could just start reading these documents, but what I'd rather do is I'd rather explore the relationships between these documents. And so to do that, I'm going to open up this. And what you're looking at is you're looking at a visualization of terms that are within this document. Now, these terms were created by analyzing the entire corpus of document in order to produce the topics and show the relationships. And so in this case, you can see that Oswald is related. One of the relationships I find interesting over here is this cluster of relationships around Sylvia. And so what I want to do is I want to dig more into that. And so let's pull up the documents related to just this intersection here. And so right off the bat, catches my eye is this document here, which is the original signed interrogation of Sylvia Duran by the Mexican government. And when I went through and I read this, I learned that Sylvia worked at the Mexican the consulate, and she was Oswald's connection to the Russian KGB in Cuba. That's crazy. How are the KGB involved in all of this? Well, let's find out. All right, so same thing. Let's see the relationships that the KGB has. You can see two big clusters here. One I'm not going to try to pronounce, so let's follow Nosenko. Who is this Nosenko character? So again, we're going to pull up all the documents related to Nosenko, but I don't really know who this guy is. Oh, and look at this. The linked entities skill is able to make a connection on this term to a Wikipedia article that exists. And so right away, I can learn that Yuri Nisenko was a KGB defector that was interrogated by the CIA. In fact, these documents are the transcript of his interrogation, including the audio recordings. Now, we could go dig into that and start reading about that and see where that takes us next, but I think you guys get the picture of what happens here. And that is that when the US government releases a secret cache of documents about the assassination of a president, you better hope that your name is not in there. Now, fortunately, my name's not in there because I checked. But interestingly, the name of one of our products is in there. So SQL Server, no, SQL Server didn't assassinate the president, but it was used by the CIA in 1997 in order to manage these same exact documents that I'm showing you today. And they were actually kind enough to provide this wonderful architecture diagram, right, of the system that they built that shows the use of secure modems and phone lines, and they use some fantastic clip art. And so I thought it'd be good to compare this against the architecture of the system that I just showed you right now. I decided, though, I'm going to reuse their classified CIA clip art, though. So the way the system works is that when the documents are uploaded into the cloud in the blob storage, it then triggers an Azure function. An Azure function that I built that implements a cognitive skill set. And this skill set contains that custom skill I mentioned that applies those code words, but it also those other skills that use cognitive services such as computer vision, OCR, handwriting, and entity linking in order to extract that information. And that the knowledge extracted from these skills is stored as annotations in Cosmos DB and put into Azure Search. Now, we also use Azure Machine Learning. We use Azure Machine Learning in order to read all of the document annotations and to produce and extract those topics at a corpus-wide annotation. And those as well end up in the search index, and that I could explore it visually like you saw, and using the AZ search, and this guy, he's just happy to be here. All right, so why don't we just dig into one of those pieces? I'm sure you're curious what the code looks like. So let's take a look now at the code for the Azure function. This is where all of the interesting stuff is going on. So let me just zoom in here. OK, so this is the Azure function that reads the blob, is triggered whenever a blob is executed. And you can see here the first thing we do is we parse these PDF documents into images. And then we create and apply this cognitive skill set to the image, which produces these annotations. We save those annotations in Cosmos DB. And then I create a search document that creates those projections. Here is the text from the document, as well as all of the annotations in the form of metadata. And then on the left, where we broke everything down by those linked those entities, this is how we surface that in the search index as well, right here. And that ends up in the search index. Now, let me show you what the cognitive skill set looks like. OK, this is the cognitive skill set. It's really simple. A skill is simply has a name that's used to store in the annotation. It has an action. In this case, we're just resizing the image, correcting its orientation, and uploading it for the website UI. And it has an input. So this is the PDF image. And then annotations produce an output. These are the annotations that will be stored. And then it also serves as the input to other skills as well. So here's the OCR skill that takes that resized image as an input and then uses the cognitive service to recognize the text and so on and so forth with the handwriting recognition, computer vision, here linked entities, and the CIA cryptonyms that I implemented as well. So it really is that easy to create a solution that can enhance the knowledge inside of the documents you have and let you explore it in a new and interesting way. Now, what I just showed you was a problem that the CIA has. But imagine now for a minute how you could apply this cognitive search pattern to your own data. So whether it be analyzing legal documents, understanding engineering plans, or just extracting information from forms. So join us as we build together the solution to power new experiences and extract knowledge hidden in piles of unstructured data. Thank you very much.
Coram, how long did it take you to build that app?
Yeah, I mean, the JFK files were just released, right? So I just started this last week,
Okay.
so not very long.
Thank you. So now AI is for everyone in every industry, whether it be healthcare or financial services or government. AI is being applied to transform customer experiences, to transform their business models, and to really increase efficiencies in a dramatic way. So these are all examples of customers who are engaging with AI. For example, on the left, Unilever. They have built a chatbot, and not just one, but a collection of them with a master bot to help their employees interact with HR services and all services inside the enterprise. It's multinational. Rolls-Royce uses AI for predictive maintenance. Cochrane uses AI to classify medical documents and organize information for systematic reviews. Publicis uses AI for makeup recommendations. eSmart Systems has a connected drone. AI is even being used to save snow leopards in the Himalayas. And there, AI is used to classify selfies of snow leopards, photos of snow leopards, and correctly organize them and do census on them. Very powerful collection of applications. So, step back a minute. Let's look at the enterprises of the past. We really had built systems of record for the enterprise to operate. We had ERP systems, we had CRM systems, most of these rather siloed. And then when the web came along and the internet came along, we built these systems of intelligence to interact with our customers. And now, what we have at our disposal is a system of intelligence. A system of intelligence integrates data across all of those systems of record, connects you to the systems of engagement, and creates a connected enterprise that actually understands, reasons, and interacts in a very natural way. And that's the power that AI is bringing to you. And when you're building systems like this, you need a very powerful platform. And it's not just one or two components, not a few components from open source. You can't just take a little bit of a deep learning component and apply a little bit of data and put it in a VM and build a system of intelligence. You need a comprehensive collection of components that only a cloud platform can bring. And that's the thesis behind the Microsoft AI platform. It's cloud-powered AI for every developer. At the highest level, you have these services that I mentioned. And we will keep innovating on this, by the way. So you have the custom AI development service, Azure Machine Learning, which allows you to go from data to a sophisticated AI model and deploy them wherever you want, right? But it's custom AI for absolutely the tier 1 developer. So we're covering the tier 1 AI and data scientist use case with incredible openness in the Azure Machine Learning platform. And then you have pre-built AI. Now, I'm a big believer that a lot of AI should be just like calling a sort function. You don't actually really have to understand what's in a sort function and the deep algorithm behind it, but you just call a sort function and you get an output. So with pre-built AI, like speech recognition, like translation, like image understanding, like OCR, we have, by the way, one of the best handwriting recognition APIs anywhere. It's used, by the way, in OneNote as well. You've seen the handwriting. The same AI is available as an API in the cloud, and that's what Coram used in his previous demo. That's examples of pre-built AI. And then when you want to put a conversational interface, like an intelligent chatbot, you have the Azure Bot Service and the Bot Framework. And then we'll keep innovating on these things, right? And so that's a higher level services. And this is all built on this incredible wealth of data and cloud infrastructure. Even today morning, you saw one of those new announcements from us that is adding to this wealth, the Azure Databricks announcement. It's a very scalable Spark-based system that is a service in which you can cook your data with all the power of distributed computing. So you will see all the databases like Cosmos DB and SQL DB and SQL Data Warehouse and Azure Data Lake for hosting your data, integrating it. And then you will see these computing environments, distributed computing environments, like the Spark environment for distributed data analysis, Batch AI for harnessing VMs in Azure Batch, Azure Container Services for Docker containers in Kubernetes clusters. and then even the IoT edge. So that's all the power of the cloud, and of course behind it is the innovations in hardware, the latest CPUs, field programmable gate arrays, FPGAs, and GPUs, and more to come. And then we give you tools. So we are announcing today the Visual Studio tools for AI. I think you already heard about it. That allows you to stitch together AI applications, not just on premises on your laptop, but in the cloud as well. And there's Azure Machine Learning Workbench, Azure Machine Learning Studio, and then we support all of these open source toolkits, Caffe and TensorFlow. So it's sort of the best of open source and the best of Microsoft's AI technology and the best of cloud all coming together in one platform to enable you to build systems of intelligence. That's the power of it. All right, so Azure Machine Learning is that custom machine learning capability. It is a great workbench which allows you to not just interact with the cloud services, but even do data transformations. Okay, there's a technology called program synthesis that allows you to dramatically simplify the effort in writing code to munch data. Then there's an experimentation service in the cloud. It harnesses the power of big data and Spark, and it also brings a full life cycle of management to AI development, version control, tracking model experiments, and so on. And then there's model management, which allows you to take these models that you built and deploy them in IoT or in Docker containers and actually monitor them while they're actually running. So that's the power of the Azure Machine Learning platform. So think about it in terms of sort of this simple equation. AI-powered data wrangling, end-to-end machine learning productivity, the ability to deploy anywhere, comprising this end-to-end tooling for AI development. That's what it is. So again, let me show you a demo. I'm sure you really want to see a great demo of what this is. This is the reasoning part of AI, building custom AI models from data, in this case, images of snow leopards, building a model to classify and tell apart snow leopards from everything else. And here's sort of the outline of the demo. We're ingesting snow leopard images, photos. You're then going to wrangle that file names and so on a little bit to structure the data from which you have to learn. Then you're going to do model training using Azure Machine Learning Workbench, train even on a Spark cluster. Then you're going to deploy the model, either using Spark streaming, so data can stream in and you can classify on the fly, or another option is to deploy them in Docker containers and deploy a web service, right? So all of that's possible. So to illustrate this, let me invite Mark Hamilton, an engineer in my team, to tell us about Snow Leopard Classifier as a Service.
Thank you very much.
Mark.
Hi, everyone. I'm Mark Hamilton. And today, I'm going to show you how to create an end-to-end real-time snow leopard detection system in 5 minutes using the Azure Machine Learning Workbench. This system is currently in use by the Snow Leopard Trust, a nonprofit organization devoted to monitoring and protecting the endangered snow leopard. I'm doing this entire demo in the Azure Machine Learning Workbench. And if you haven't already checked it out, I definitely recommend it. It's a great tool for creating end-to-end machine learning applications, and it also doubles as a nifty replacement for PowerPoint. So a bit about snow leopards. There are only about 4,000 to 8,000 left in the wild, and they face a variety of threats from mining and poaching to retribution killing. These 4,000 snow leopards are spread out amongst 1.5 million square kilometers of territory, making them incredibly rare to find and study. So we really don't have a good idea about their behavior, habitat, or population dynamics. And if we want to protect these creatures and their habitat, we need to understand a bit more about where we should protect so we can focus our efforts. This requires a huge amount of data, and that's what the Snow Leopard Trust has been collecting over this past decade through a large system of remote camera traps. Over this time, they've collected 1.3 million images, and while they have one of the largest data sets of snow leopards on the planet, they also have one of the largest data sets of mountain goats on the planet. And this is the problem, because for a human to actually go through and manually sort out the snow leopards, we estimate that it'll take more than 20,000 hours to actually do this. And this is an insurmountable problem for a small nonprofit of about 5 people. So this is where we come in to help. And today, we'll show you how to build our real-time detection system using Microsoft's new open-source distributed deep learning library, MML Spark. But before we dive into the code, this is real-world data, and you didn't think it'd be really this easy, right? So the data that we have, it's a horror. It's in 17 million different formats, and in order to actually work with it, we need to clean it up a bit. Thankfully, the Azure Machine Learning Workbench has a data preparation tool that makes this unbelievably easy. For example, I want to pull out the name of this survey and put it into a normalized form. Automatically, it starts to try to figure out what the pattern is. And I can easily fill in more examples so that the algorithm gets better. And you don't need to sit here figuring out examples for a while. After only 2, it's fully understood the pattern that I was going after, even in the presence of weird edge cases. And this is a real game changer, because previously, the way to work with your data was to use pandas and to print the data frame out between every single step. And this takes a huge amount of time. And if I really didn't have this tool to work with all of the 9 different surveys and condense them into one single place, this would be a 4-hour talk on regular expressions and not a quick demo. So you have this to thank. So the first part of, now that we have the data wrangled, we want to actually move it into Spark so that we can work with it. Spark makes this incredibly easy to load data from a variety of sources and split them up into a training and testing set using the full parallelism of the cluster. Then, once we have our data in, we can think about how we want to model it. We're going to use transfer learning, or the idea that we take a neural network that already understands a lot about natural vision, and we're going to fine-tune it to become an expert snow leopard detector. We do this by taking ResNet 50, Microsoft Research's award-winning, very deep convolutional network, and we're going to cut off the final layers of it that are a little bit domain-specific and put in our own SparkML logistic regression. This is incredibly simple to do with MML Spark. In only about 5 lines, we can download the network from our large repository of pre-trained models, plug it into our pipeline, add on logistic regression, and then package it up into a single model that we can use and work with. Then it's only about 2 lines to fit the model on the training data set and actually use it to get some predictions. I've already gone ahead and run this ahead of time, but it only takes about 3 minutes because it leverages the full parallelism of the cluster. So you're only 3 minutes away from a really solid model. Then once we have the model, we can work with it and understand interactively its performance using tools like Matplotlib or Bokeh. Now, once we're satisfied with the model, we can move ahead to production. In this case, we use Spark Streaming, a distributed and fault-tolerant streaming architecture that allows you, that has great integration with other open-source frameworks like Apache Kafka, a low-latency log aggregator that allows us to pull in data and images from all of these camera traps and amalgamate them into one place so that our pipeline can operate on them. Finally, we're going to push this data out to Power BI, Microsoft's powerful visualization tool that will let us really dive deep and explore the data and publish interactive dashboards when we're ready. If incredibly low latency applications are more your thing, we also have an option using the Azure ML command line. In just one simple line of bash, you can take this model that we've trained and export it to a Kubernetes cluster, where it can serve as a low latency endpoint for any of your applications. So now that the application has been streaming for a little while, we can go over to our Power BI dashboard. In real time, we'll get updates on snow leopard images, and we'll see all of our streaming results come in. What's really nice about Power BI is that it's incredibly easy to create these kind of rich interactive visuals and also to analyze them if we want to take a look at a specific survey or a specific area in order to find out where leopard territory really is. Alternatively, we can actually use our Kubernetes endpoint to create a real-time service that can be used for prediction. I'm always amazed how easy it is to actually create these really rich, robust apps using the Azure platform. We really stand on the shoulders of giants when we work with these unbelievably robust tools, And it allows us to create applications instead of taking months or years to build one of these large systems. We can do it in a matter of minutes or hours. And this is really important because it frees up a lot of time for these organizations like the Snow Leopard Trust to, instead of worrying about mucking with code and worrying about parallel distributed processing, to actually think about bigger problems like protecting the snow leopard. Thank you all for listening, and have a great Connect.
Thank you, Bob. Wonderful. So today we announced the Visual Studio tools for AI to keep pushing the envelope for every developer to be a proficient AI developer. It's integrated with Azure Machine Learning. So you can actually work on your laptop, but do the computation in the cloud. It allows you to create new deep learning projects extremely easily, to scale out in the cloud with batch AI. It has a lot of templates that make development with Caffe and TensorFlow and Cognitive Toolkit all much easier. And you can also monitor the model training progress in the cloud and things like the GPU utilization. Just makes it much, much easier in a familiar Visual Studio environment. So now I want to talk a little bit about AI at the edge. The cloud is fantastic for learning. And for SaaS applications, software as a service applications, it's great to have AI run right there in the cloud. But often, a number of your applications are going to run on a phone or on an IoT edge device, and you want the ability to have the machine learning inference, the scoring, actually happen at the edge. And that's where AI at the edge becomes important. So it gives you low latency, and it also allows you to operate AI with reduced internet connectivity and in compliant ways, right? And so let me show you a demo here. So I'm going to talk about real-time AI on mobile phones and edge, okay, a model deployed on the phone. And in this case, it's an image model. It's a heavy image model. The scenario is this. Skin cancer detection, okay? There are public data sets available now for cancer detection, images of skin patches and patches labeled with high risk for skin cancer, like melanoma, and patches that are not high risk. And the task here is to learn a classifier model and then be able to deploy it on a phone. So here is a scenario. We take this large data set of cancerous images of cancer and not cancer, skin patches. You then learn a deep learning model using Azure Machine Learning. Then you export it to CoreML. CoreML supports inferencing on Apple iOS devices, on iPhones. And then you actually have a Xamarin app that allows you to just hold a phone over your skin and see the risk associated with that, right? It's a very interesting app to build. So to show this, let me invite Anuswa, a data scientist in my team. Anuswa?
Thank you so much, Joseph. Hello, everyone. I am a data scientist in Microsoft, and today I'm going to wear my developer's hat and tell you how we can use Azure ML Workbench to create Edge AI. For that, I'm going to first switch onto my phone. I actually have already developed an app and deployed it in my phone. Sorry about that, it's not working. Yes, now it's coming. Okay, so I have two versions of the AI app which I have developed on my phone. One is a photo version, another is a video version. So first I'll start with the photo version. This app actually takes a photo as an input and tries to give me a risk associated with it. Let me choose some of the images which I've already preloaded my phone with. For this image, it says that I'm all clear. I do not need to go see a doctor. Let me choose another one. For this image, it tells me that there is a risk associated to this image, and please go see a doctor. But what if we can actually show this classification in real time? What if my app can actually take a real-time video feed and can predict if I need to go see a doctor or not? Let's try that out. For that, I have some prop images here, which I will be using. So as you see, it's trying to give me whether that this image is a critical one and I should go see a doctor. Let me actually try this out on my skin. And it says, I am all clear, okay? So thankfully for you, yes. So with that, let me actually dive deep and show you how we developed this app. For that, let me switch onto my Mac. The thing that you see here is basically the Azure ML Workbench. I've already uploaded my codes in here. Azure ML Workbench actually helps you create a cross-platform desktop application where you can actually create end-to-end custom AI model for complex data set like healthcare data. So what this tool is giving me is all of my run histories, which model is actually good, which one has failed, which one has run successfully, all of this. Now let's dive into the code. I have first created a model with Keras and TensorFlow backend. I run a 2-layer convolution neural network and train the ISIC cancer dataset. It is a research dataset, and it's open. I've used 80% of the images for training and 20% of the images for testing. Now let's see how the test scores are on that test dataset. And with that, I've already trained my model, so let me show you that the test accuracy is pretty high. It's coming out to be 88.88%. Now let me try and create a scoring function for this trained model. Here, I have actually loaded up in my init function a trained Keras model, and I pass a test image onto the scoring function. I've already run it, and as you see here, for this particular test image that I'm passing to my scoring function, it's flagging it as a critical image and telling me that that I should pretty confidently go see a doctor. So that was the whole Azure ML Workbench end-to-end scenario where you bring your data in, you train your model, you score your data. Now, you can also deploy your model using simple Azure CLI commands and run it on any Azure IoT. So how can we run it on the iPhone that I showed you? For that, we'll actually use CoreML. We have created the model in Keras. Now we want to convert into CoreML format. CoreML helps you bring machine learning abilities to your iPhone and Mac. What I have done is I have pip installed the CoreML package in my Azure ML environment. Now I've loaded up my Keras trained model here, and then I actually tell the CoreML tools to do the conversion and save it in a .ml model format. Once the model is created, I run the xcrun command of CoreML to compile the model. Now all I need to do is bring this trained model onto a Xamarin app. Let's see how. You've all seen Anna's demo today morning. So I am using the same app as an example. So I've loaded up the sample app, and I have dropped my custom AI model into the resources folder there. Now I go to the viewcontroller.cs. What I do here is I actually point it to my custom model that I have dropped here, right? This model. And I have dropped it here. So I just changed the model path. One line of code change. Then I go to the prediction function, and there I create the prediction logic that I want to show. For example, if the class label is benign, then just suggest that you're all clear. If the class label is malignant, just say you should go see a doctor. Okay? So as you can see, with just 3 lines of code change, we can bring any custom AI model onto your Xamarin app and run it on your iPhone. I look forward to see how you use the Azure ML Workbench, CoreML, and iPhone OS together to build more cool apps like this. Thank you.
Thank you. Thank you. Fantastic. So today we announced the Azure IoT Edge, and we have a great AI toolkit for the Azure IoT Edge. You can go to that GitHub example, the link down there, and you will see how you can actually use Azure Machine Learning to train and then deploy models on the IoT Edge for deployment in a factory, deployment in manufacturing environments. All of that's available. So let's talk about pre-built AI a little bit. Now, over time, I expect the cloud to have a vast number of intelligent APIs. Today, there are already about 30 of these very sophisticated APIs. APIs for vision, APIs for speech, APIs for understanding language and translating it, for knowledge and search. And we announced also, sometime earlier, many of these can be customized, at first in the cloud. For example, custom speech. Custom speech that can be trained to your language, your vocabulary, your accent. Wouldn't that be powerful, right? And so customization, limited customization is going to come to every one of these kinds of APIs. And then when you need very deep customization with large amounts of data, you fall back to things like Azure Machine Learning and build with the sophisticated tools that are available there, right? And so these things work together. And then you come to the bot service. A lot of applications for speech recognition and translation and all of that is in conversational applications. And the Azure Bot Service and the Bot Framework make it really easy to go build these applications. For example, the Bot Framework is behind all of Microsoft's first-party bots, whether it be, or even Skype and Messenger platforms, it uses Bot Framework. So you can take Bot Framework or the Azure Bot Service, you can connect it to cognitive services and build a very powerful bot that allows you to be very useful. Now, don't pretend these bots are humans, by the way. As I say often, all artificial intelligence is dumb, but some artificial intelligence is useful. Okay? So you're going to build useful bots that allow you to do task completion and create great efficiencies in the areas that you want it to create efficiencies. Okay? So that takes me to my fourth scenario and the fourth demo. This is intelligent bots. What we're going to show is a conversational AI application that actually is running on a developer's favorite website, Stack Overflow. So to talk to you about this demo, let me invite Wei Hong.
Thank you, Joseph. Now, Stack Overflow, as we all know, is the world's largest developer community, right? And this morning at the keynote, you saw the Stack Overflow bot in action, or rather a video of it, right? And today, I'm super excited to show you the Stack Overflow bot and how we infuse it with all this AI that Joseph talked about, right, in action. Now, to do that, let me switch to my machine. And as we all know, right, as developers, we might be wanting to pick up some of this machine learning, deep learning skills. And right now, right there in Visual Studio Code, I'm developing a machine learning model using scikit-learn, right? And as I walk through the model, you'll see that, well, many a times you get to a point where you might be using a function. And in this case, this is a function called logistic regression, and we're using it as a way to classify images, right? Now, many a times we say we have our developer buddies, we have our best friend, and Stack Overflow is our best friend, right? What if right here inside Visual Studio Code, I can start up a Stack Overflow bot, and right here in Visual Studio Code, I can start interacting with the Stack Overflow bot. Now, let's wait a while for the bot to start up. Of course, this bot is going to help you do many, many things. I'm going to show you a subset of this. And at this point, I might say, hey, I want to be able to optimize this particular function, right, using scikit-learn. Now, observe what happened when I click Enter. This is going to use Bing Custom Search, which is one of the cognitive services, go up to the cloud, and it's going to come back with relevant results, which is what you see here in the first row. But we took that a step further. We said, well, with Azure Machine Learning, we have a really great environment for you to build machine learning models, right? What if we can leverage the public Stack Overflow data, build a custom category prediction model on it, but more importantly, deploy this as a web service, and after we have deployed as a web service, consume this in an intelligent bot that you see here. And this is essentially the categories that got returned, right, from the machine learning model that we have built. Now, at this point, you say, well, this is great, right? I have the bot right there in Visual Studio Code, but what else can I do with it? Well, many a times as you work with all this code and so on and so forth, you might want to install additional package. In this case, I might want to update it with a new Python version. And when I update this, I might get a dialog, and I might need help. And I could say, hey, can you help me with a Python installation dialog? Now, observe what happens again, right? At this point, it's going to say, well, give me a screenshot. I'm going to upload a screenshot of a Python installation dialog. And right now, what is happening again is taking this screenshot, sending it up to the cloud, using the OCR capabilities, the same thing that you saw in Chrome's demo, right? And then extracting out the text and passing it to the text analytics API in order to get the key phrases. And of course, I could search the full text. Now, once this is all done, of course, I could interact with it. I could say, well, thank you. You need to praise the bot as well, right? And with that, right, we are finished with the demo, but this same piece of code that you see here is posted on GitHub, and we're super excited to see how you and us as a developer community, right, can take this, infuse it with more AI, right, and create even more exciting experience, empowering developers to build the future. Thank you.
Thanks, Vihan.
Thank you.
You know, we're just getting started with conversational AI. There's an incredible, bright future ahead of conversational systems because of the rise of the messaging platforms. You know, take a look at what Vihan actually did. This sort of recapping. There's a bot that runs in Visual Studio Code. It's tapping into this brain power available in the cloud with cognitive services, orchestrating a lot of cognitive services with Azure functions, even custom web services that you might create with Azure Machine Learning and deploy in the cloud, right? And you can involve that intelligence in the cloud, and the bot will get smarter and smarter over time. Very powerful. So let's recap. Here are the Microsoft AI platform capabilities I talked about. Cognitive understanding, the ability to use this pre-built AI and custom AI that you might build to understand the content of every type of media and information, videos, images, natural handwriting, other things, and organize it. And then reasoning, right? Building custom AI models, real-time deployment at the edge, and then building cognitive applications that really infuse AI into every type of software to make it look really intelligent. And then finally, conversational AI. Powerful bots that keep improving and help make interactions with users dramatically more natural and simple. So I invite all of you to take advantage of these capabilities. There are a lot of resources available on Azure. Azure.com/AI is your starting point. And we also announced an AI school. AIschool.microsoft.com has tremendous number of resources, both in terms of training and examples and other things there for you to get started in this journey. Welcome to the new world of AI-infused software. Thank you.